So let us start with the thermal motion of electrons. Okay, let's talk about the thermal motion of electrons. Now you try to understand here that the electrons, you see, at room temperature, these electrons, they undergo random motion. Okay, they undergo random motion as it is shown here. Here you can see that if we take an imaginary surface, okay, suppose we have taken an imaginary surface here. Okay, so the number of electrons which are going from left to right or crossing this surface left to right are equal to number of electrons which are crossing right to left. Okay, what does it mean? It means that actually these electrons are in random motion. Okay, they are in random motion. And at room temperature, the speed of electrons due to the thermal motion, because this is the thermal motion, because of the temperature this motion is. So this thermal motion, because of that, the speed is around 10 to the power 5 meter per second. Okay, however, you see here that these electrons are moving randomly, but their motion is not in a certain direction. Okay, their motion is not in a certain direction. What does it mean? That the directional motion is missing. Directional motion is missing. And if the directional motion is missing, then we will say that actually electrons are not moving in a certain direction. That's why there is no current flowing. Okay, there is no current flowing. Make this thing very clear. No current is flowing there. Okay, now as you can see here that if you increase the potential difference, you would find that the greater current would flow, and if you decrease the potential difference, lesser current would flow. Okay, Ohm's law, which we discussed, that the current is directly proportional to the potential difference applied. We will be talking about that also. Okay, having said that, here you see that the direction of current here is from left to right. Okay, direction of current is the conventional current. Okay, we discussed about the conventional current and the simple current. Okay, that is the electric current. And you know that we always plot the conventional current in the circuit. We always draw conventional current only in the circuit. Okay, now you see here that electrons are undergoing random motion. Okay, now here they have shown current direction, but basically it is not the conventional current, it is the electric current, because here we are showing the electrons. Okay, anyway, you see these electrons, they are moving from left to right. What does it mean? It means that if the electrons are moving from left to right, if electrons are moving from left to right, it means that there is directional motion of the electron. Okay, electrons are undergoing directional motion, and it is because of the potential difference. Why the directional motion is there? It is because of the potential difference applied across its ends. So this end is negative potential and this end has positive potential, and now the electrons are moving from left to right. Okay, do remember this, that when electrons are actually moving in a certain direction, the reason behind it is because there is an electric field which is set up. When we create this potential difference, there is an electric field which is set up. Okay, electric field is set up. And do remember that because of this electric field, under the influence of this electric field, what happens, that these electrons, they get accelerated. Okay, these electrons, they get accelerated. Okay, electrons, they get accelerated. Okay, they get accelerated. And if these electrons are getting accelerated, then what will happen? You know that their velocities will increase. Okay, so this way velocity should keep on increasing, right? But it doesn't happen. Velocity doesn't keep on increasing, but what happens, that it acquires a constant velocity. Electrons, they acquire constant velocities, and then they start moving with this constant velocity. Okay, the constant velocity with which electrons they start moving, this constant velocity is called drift velocity or drift speed. Okay, so this is what the drift velocity is, the constant velocity with which the electrons they start moving, okay, under the influence of the electric field. This is what is called, this is what is called drift velocity. Okay, do remember that the value of drift velocity for an electron is around few millimeters, say 1 or 2 millimeter per second. Okay, what does it mean? In a second it travels a few millimeter distance, okay, not more than that, right? Now this is something very interesting. Why I am saying it is very interesting? Because suppose that there is a long wire. Okay, there is a long wire. Suppose that this wire is of 1 kilometer length. Okay, this wire is of 1 kilometer length, and suppose here at the end of this we have an electric bulb. Okay, at the end of this here we have an electric bulb, and then again this 1 kilometer wire is there, and then so this 1 kilometer makes it 2 kilometer length, and then we connected it with a battery, and then a switch is there. What happens when we switch it on? When we switch it on, what happens? You see, now because the drift speed is a few millimeter per second, is of a few millimeter per second, what should be there? It should take some time for this electric bulb to glow. But do you know what happens? Surprisingly, as soon as you switch on this switch, bulb starts glowing instantly. What does it mean? It means that there is something wrong in our concept. Okay, when we switch it on, there should be some time for the electrons to reach there and glow this bulb, but it is not happening. What is happening instead is it is glowing instantly. How is it possible? There is actually some contradiction. What we are saying is contradictory to the concept of drift speed. Now do remember this. The solution of this particular problem is that, do remember that whenever we switch the circuit on, when we switch the circuit on, an electric field is set up. There is an electric field which is set up, and this electric field which is set up, it is set up with the speed of light. Okay, this electric field is set up with the speed of light, and that's why in the entire wire the electric field is set up. Okay, it is set up everywhere, and that's why it will not happen that the electrons of this end will reach there and they will glow the bulb. No, it will not happen. Instead, what will happen, that here, because the electric field is set up throughout the conductor instantly, that's why the electrons of this point only start moving, and that's why you can see that the bulb, it starts glowing. Okay, so that's the point. Okay, and that's why do remember that the drift speed is extremely important. Okay, but you know that what happens, that when we switch on the current, when we switch on the circuit, what happens, that the electric field is set up with the speed of light, and that's why instantly this bulb, it starts glowing. I hope that this is clear to you. Now let us talk about one more very important topic, which is factors on which resistance of a conductor depend. Okay, so on what factors does the resistance of a conductor depend? Now you see here in this particular motion of the electrons, you know that these electrons, they will collide with each other. Okay, do remember during their motion, okay, though they got the directional motion now, but during their motion, what will happen, that the electrons, they will collide. Okay, and when these electrons will collide, you know what happens, that they actually resist their motion. Okay, they resist each other's motion. Okay, and this is the reason, this is the very reason behind the resistance of the conductor. Okay, this is the very reason behind the resistance of the conductor. So do remember that the resistance of a conductor is directly proportional to the length. We are now talking about, the factors on which the resistance of the conductor depend. Okay, once again, do remember that the random motion of electrons, it gets converted into the directional motion, but you know that there are collisions, and because of these collisions, what happens, that because of these collisions the resistance is actually produced. Okay, so what is the reason behind the resistance? It is the collision between the electrons, collision amongst the electrons of the conductor. Now this resistance is directly proportional to the length of the conductor. What does it mean? It means that longer the length of the conductor, more would be the resistance. Okay, longer the length of the conductor, more would be the resistance, because you know that more collisions would be there. Okay, also shorter the length of the conductor, lesser resistance would be there. Okay, having said that, resistance is inversely proportional to cross section area. Okay, resistance is inversely proportional to cross section area. What does it mean? If you have a thin wire, okay, if you have a thin wire, then you will find that the resistance of this thin wire is more. Okay, however, if you take a thick wire, okay, if there is a thick wire, then you will find that the resistance of this thick wire is actually lesser, because the cross section area, this is called the cross section area. What is called the cross section area? This is the cross section area. Okay, and this resistance of, you see this second wire, this is the first wire, this is the second wire. In case of first wire, the area is lesser, and as we know, resistance is inversely proportional to cross section area. It means that lesser the area, more would be the resistance. More would be the resistance. Okay, lesser the area, more would be the resistance. Right? Also, in this particular case, you see, area is greater. If area is greater, resistance would be lesser. If area is greater, resistance would be lesser. Okay, what does it mean? It means that greater the area, lesser would be the resistance. Okay, and that's why we can say that resistance is inversely proportional to cross section area. Now, if we combine these two results, you will be getting, this implies resistance is directly proportional to length and cross section area. Okay, resistance is directly proportional to length upon area. This implies, you know what happens when we remove the proportionality constant? Whenever we remove the proportionality constant, whenever we remove the proportionality sign, sorry, a constant comes, and this constant is rho. Okay, this constant is rho. Okay, rho L by A. Now, what is this rho? Rho is called resistivity. This rho is called resistivity of the, now listen, this is extremely important. This is called the resistivity of the material of that conductor. Material of the conductor, resistivity of the material of the conductor, resistivity of the material of the conductor, material of the conductor. Okay, what does it mean? If it is of copper, then this is the resistivity of copper. If this wire is made up of say aluminium, then this is the resistivity of aluminium. Okay, and that's why we can say that this rho is the resistivity of the material. Okay, now how can we define it? Let us talk about this a bit, that how can we define resistance. You see, resistance is equal to rho L by A. Now we have to define this resistivity. How can we define this resistivity? Try to understand this. Okay, here you can see, that rho is equal to R into A upon L. Okay, now what happens? Rho is equal to R A upon L. When we say this, you know, if area is 1 meter square and length is 1 meter, this implies R is equal to rho. Okay, resistance is equals to resistivity. What does it mean? It means that if you have a conductor of length 1 meter, if you have a conductor of length 1 meter and cross section area 1 meter square. Okay, if there is a conductor of length 1 meter and cross section area 1 meter square, what does it mean? It means that the volume of the conductor is 1 meter cube. Volume of the conductor is 1 meter cube. Okay, so volume of the conductor, if it is 1 meter cube, then you can see that if we substitute these two 1, so we will be getting, this implies R is equals to rho. What does it mean? It means that resistivity is the resistance of a conductor whose volume is 1 meter cube. Resistivity is the resistance of a conductor whose volume is 1 meter cube. Okay, so if we have a conductor of volume 1 meter cube, then the resistivity is said to be, resistivity of that conductor is equal to resistance of that particular conductor. Okay, rho is equal to capital R. Having said that, do remember that resistivity is the characteristic of the material of the conductor. Okay, resistivity is the characteristic of the material of the conductor. It is the characteristic of the material. It is the characteristic of the material of the conductor. Okay, what does it mean? It means that if you change the conductor, resistivity will change. But do remember, suppose that we have a copper wire. Okay, suppose there is a copper wire, and in this copper wire, if we cut it in two halves, okay, so there is this copper wire. Okay, there, now we get two half of this. Okay, now if suppose resistivity of this is rho, okay, of this entire wire is rho, then do remember that resistivity of this conductor and this conductor, both, for both the conductors, resistivity would remain same. Ask me why. Do remember do remember that resistivity would remain same because it is still copper wire only, and you know that resistivity is the resistance of unit volume of that material. Now when we break it into half or cut it into half, you know that copper will remain copper only. It is not going to become diamond or something like that. Okay, and because both the wires, they are copper only, they are made up of copper only, that's why the resistivity of both the wires would remain same. There won't be any change. So this is what is the factor, these are the factors on which the resistance of a conductor depend, and this is what the resistivity is. So what do we call rho? Rho is called resistivity. Rho is the resistivity. Okay, rho is the resistivity. Okay, resistivity. And do remember the unit of resistivity. Rho is equals to Ra upon L. This was the relation. Okay, and if we go for this, you know, R is ohm, area is meter square, upon length is meter. So if we cut this, we'll be getting ohm meter. Okay, so the resistivity of the conductor is ohm meter. Okay, so this is what is the concept of resistivity and concept of resistance also. Once more, you remember that concept of resistance, as far as the concept of resistance is concerned, resistance means the oppose in the motion of electrons. Whenever the electrons are moving in a certain direction due to the applied potential, do remember that what happens, that the due to the collision, the motion of the electrons is opposed, and this is called resistance. And then we discussed about the factors on which resistance of a conductor depend. I hope that this is clear to you. Thank you.